In this video I'm going to show you how to use R to do a simple linear regression model. In particular, I've imported some data which is from autotrader.com. It's the price of Porsche in thousands of dollars and its mileage also in thousands. We have 30 observations and this was gathered from autotrader.com. Our job is we want to use mileage to predict price of a Porsche. And all these Porsches are the same model. So the first thing that's important to do with data is to go ahead and plot it. So I'd like to plot mileage on the x-axis and price on the y-axis. Two commands you can use. I'm going to use the base function. First argument I got to give it is the x value. Second is the y variable, not value. Now here you can see the plot and notice how it uses the default names. And you can see there's sort of a trend that as mileage goes up, price goes down. Of course, it's not a perfect relationship. Now I'd like to make it a little prettier. So the way you can make it prettier is you can tell it what to use for the X label. So for instance, I can use the command xlab, X label. And I can say that's what I want to be mileage. Likewise, I can tell it Y label. And that's price. It's a little cleaner. And some other options you can add. If you want a main title, use the command main, Porsche price versus mileage. And you see how it makes it a little cleaner. A nicer plot function than the built-in default one is one using ggplot2. If you look in your packages, you should scroll down and see if you have ggplot2. For me, there it is. If you don't, you need to install the package by typing in ggplot2, and it'll go out to the site I already have installed, so I won't do this. But I'll go ahead and load it, and now I have it. Now ggplot2 has a base command called qplot. Let's say qplot. And notice how it does a little nicer job with the size of the dots and putting the grid on there. And likewise you can add labels. So I'll go ahead and just change plot to qplot. And we have the nice labels on there now. Alright, so that's our plot. Again, it looks like there is a nice relationship between mileage and price. As mileage goes up, price will go down. So next thing we want to do is fit a linear model. I'm going to save my results in a term I call mod1. You don't have to save it. In fact, let's start by not saving it. The command I want to use is lm, linear model. And we're going to introduce the some of the terminology. The response variable, the dependent variable is price, and then I'm going to use this tilde symbol to denote it's a function of. And if I wanted an intercept, I could put a 1 in here, plus then the one dependent variable. Do a regression. Of course, I have to tell it what the data set is. That's the mistake I made. So the data set is Porsche. And there it went ahead and calculated the intercept at 71 and the slope. So again, if my Porsche had no miles on it, I'd anticipate the price to be around 71,000. And for every 1,000 miles addition I have on my car, the price goes down by $589.40. That's what that tells us. Of course, I don't need to put the 1 in there, the intercept. So there's the same command without it. If I didn't want an intercept for some reason, if I wanted to go through the origin, I could put a -1. And notice now it's forced it to go through the origin. And it's not going to be a very good model. Alright, let's save our results in mod1. So this is the one I think is the best. That way I won't have to keep typing commands over and over. There it is. Mod1, it's saved. If I type mod1, it's going to tell me here's was the formula I used, the call, and here's the results, the intercept and the mileage. Right? And that was fit using least squareds. And again, we talked about interpreting the coefficients. Okay, some other things we can look at. Let's see what else is contained in mod 1. So I'm going to say names. This tells me all the names. Alright, so I got coefficients, I have residuals, that's the difference between observed and predicted. I have terms, I have models, I have fitted values. Those are my predicted values. So for instance, if you're interested in mod 1 fitted values, let's just see what it does. There they all are for the 30 observations. These are the predicted values. Residuals would be the difference between the fitted and the observed. So these are the errors. So the first one, difference was almost $11,000 in price. Alright, so those are some of the features. Now, suppose we wanted to predict or estimate the price for a Porsche that had 21,500 miles on it. So we could do that by using the predict command. We want to predict. The model that we want to use is mod 1. Then we need to tell it, here's a new data frame, because it operates, mod 1 operates, or predict operates on the data frame. What variable? Mileage, and that's 21.5. It's going to predict a excuse me, it's going to predict a price of $58,419 for a Porsche with 21,000 miles on it. And of course, if you wanted to give it several values, you could use the concatenate function, C, 21,000, and let's say 45,000 miles. I'm going to finish my parentheses. So there's the two values, 58,000 for one with 21,500 and 44,000. So that does a nice job of predicting. And finally, suppose we wanted to add the regression line to our plot. So let's go back to our plots over here. If we wanted this one, we could just use a command called add baseline of mod 1. Gotta make sure that I have the window open with the plot that I want the line added to, and you can see the line added there. That's the regression line. Not a bad fit. Or if I wanted to do it with qplot, and what I have to do is tell it I want to add two geometric figures. I want a point and I want a smooth curve, and I have to tell it how I was going to figure out what that smooth curve is. So I'm going to say method is linear model, and I don't want any standard errors yet. We'll talk about those in a few lessons. And over here you can see the plot with the line added. So qplot, you have to tell it within the command to add the line. And that's an introduction to doing regression in R.